So what I'd like to do now is consider a problem where you're given 2 points and asked to find an exponential equation that goes through those 2 points. And you might have some homework problems like this to look at, so I don't want you to be surprised when you see them. So let's consider a problem like this. Suppose we'll look at 2 of them. Here's one where you have the point 0, 1, and then you have some other point out here, 5, 1/32. And there's going to be an exponential equation that goes through this. The question is, what is the formula for that exponential equation? Okay. So exponential equations in general look like this. Y equals a times b to the x. So if we can figure out what a and b are, then we know our equation. All right. So I will tell you, in a problem like this, if you're given the y-intercept, you should be really happy. And here's why. Watch what happens when we plug that point into this equation. We get 1 equals a times b to the 0. And then b to the 0 is just 1. So we get 1 equals a. That means that we have at least one part of our equation already. Y equals 1 times b to the x. So what can we do next? Well, we didn't use this point yet, so I'm going to plug that in now. We get 1/32 equals 1 times b to the 5th. And that's one equation with one variable, so we should be able to do that. Okay, now how you solve this this could vary. In this case, I might just look at it and say, oh, I know what b has to equal. B has to be a half, because a half times a half times a half 5 times would give you 1/32. Some of you may decide, okay, I know what power I want to put on both sides of this. If I want to get rid of that exponent of 5 up here, I'm going to raise this to the 1/5 power. Because I know in this situation, when I multiply those exponents, I'll get 1, and it'll become b to the 1. Well, if I'm going to raise the right side to the 5th power, I have to raise the left side to the 5th power. And then the 5th root of 32 is 1/2. So there you go. Now you have it. The final answer to this question is y equals 1 times 1/2 to the x. Okay. So let me reiterate. What made this question pretty straightforward to do was that we had the y-intercept. It's easy to think of a case where you wouldn't, and then things become a little bit more difficult. So let's look at one. Let's consider this problem. Suppose we have an exponential function has this general shape, and you know that this is the point -1, 1/15. And then up here, this is the point 2, 9/5. So now you don't have the luxury of having the y-intercept, which means that when we plug in either one of these points, we're not going to have b to the 0 power. B to the 0 power is nice because it gave us 1. It's not going to happen here. So we'll just start with y equals a times b to the x, and I'll plug in the first point. 9/5 equals a times b squared. Okay. And the problem we have is there's no way to solve that and say a equals a number or b equals a number. We could get a alone or b alone, but we can't actually get the value of a or b yet. So we're going to have to plug this other point in. If we do that, we get 1/15 equals a times b to the -1 power. Okay. So from this point, I can think of 2 ways that you can go. One way would be take maybe the bottom equation, for example. Take this one here, get a alone, and then plug it into this equation and try and solve. Plug it into the one above. You could do that. Or there's a second way. This is a little bit more interesting that I want to show you. So here's an idea. What you can do, actually, provided that neither side of the equation is 0, which is not, we can actually divide these equations. And sort of a fun thing happens. So we've got 9/5 divided by 1/15. So we can do that quickly. That's really 9/5 times 15/1. And if you give that a little bit of thought, that's just 27, right? Okay. Sort of makes sense. There's 27 1/15 and 9/5. But here's what's more interesting. On the right side, when you divide a by a, they cancel out and give you 1. So now I've gotten rid of one of my variables. And then additionally, we also know that if you have b squared divided by b to the negative 1, since we have the same bases, we can subtract those exponents. And on that side, we'll get b to the third. And that's surprisingly nice now. After all of that, b is just 3. So we're on our way to getting our equation. Our equation looks like y equals a times 3 to the x. Okay. Well, I also have the advantage of knowing 2 points this goes through. I can use the point up here, negative 1 1/15, or 2 and 9/5. That's what I'm going to use there. So I'm going to say 9/5 equals a times 3 to the second. And now I can find a. So I get 9/5 equals a times 9. So you can sort of look at this and tell a must have been 1/5. How do I know that? Because 1/5 times 9 would be 9/5. Okay, once you've done that, you're done actually, because now you have your equation. Y equals 1/5 times 3 to the x.